Hey guys, welcome to another lesson. So today we're looking at circuits, right? A circuit is just a pathway that current will allow to be flown from the source around to some other appliances or loads and then back to the source, right? So we know that we have some terms here that we're going to define, but this class will be mainly based on doing some little calculations based on the types of circuits that we have. So the terms that we need to revise here is voltage or the potential difference, right? And what this is, it's basically the difference with the charge concentration from one side of a load to another side of a load, right? And a load is basically a device in the circuit that has a resistance, right? So that's the reason if you're supposed to find the voltage or the potential difference between 2 points on a straight wire that's just connected to a battery, you're going to get zero, right? Because there is no resistance to slow down the charges, so you have a difference in the charge on one side to the difference in the charge on the next side, right? Current. So current is the rate at which charges flow, right? And we can use this equation to remember that definition. So Q equals IT. So Q is the charge, so I is Q over T. So it's the rate at which charges flow per second, right? So every second in the circuit, how much charge is being passed in a point at that specific period of second, right? And the electromotive force, which is the EMF. So this quantity or this term is normally mixed with voltage or potential difference. It's the same principle, but it only EMF, we only talk about it in a source. So the EMF is the source, right? And the EMF is the rated source, voltage source of a battery or a cell, right? So when you buy your battery and it says 9 volts, that is telling you that's the EMF. That is the maximum voltage that the circuit can actually get, right? So if you want a 12 volt in your circuit for an appliance, you cannot use a 9 volt battery, right? Because the EMF tells you the maximum voltage that can be supplied to it. And then the resistance. So resistance is the impeding of the flow of current. So charges are moving, right? So once you have an impeding, meaning you're slowing down the movement of the charges, then that's known as resistance. All right. So with circuits, we have our famous Ohm's law, right? And Ohm's law states that a potential difference or the PD between 2 points is that proportional to the current that's flowing, provided that the temperature is kept constant, right? Because when current is moving, you have a tendency of producing heat, right? So if the heat amount is not exceeding to create a difference in temperature, then Ohm's law stands firm, right? So we get V is equal to IR. The V there represents the potential difference or the voltage, I is the current, and R is your resistance value, right? Now the equations that you will use as well would be power is equal to current times voltage, or power is equal to voltage squared over R, or power is equal to current squared over current squared times R, right? So this equation is the one you just need, right? So all we did was, instead of current, we made current the subject here, which is current is equal to V over R, and we substituted where current is. All right, so we get this one. And if instead of substituting current, right, we can substitute V, because V is equal to IR. So it would be I times IR, which is I squared R. Right? So you just need to remember this one in Ohm's law, so you can substitute to get those depending on what you got for your question. Alright, so let's look now at the types of circuits. So we have generally two types of simple circuits. It's a series circuit or it's a parallel circuit. Now the series circuit is basically just a one path for current to flow. So it doesn't matter what the loads are in the circuit, it's just from the battery or the source, takes one direction, right, to reach around to those loads and then back to the source. So in this case, the battery is here, so the current leaves the battery, right, passes through resistor 1, passes through resistor 2 and comes back to the source, right? So because of that, the total current that is flowing from your battery is the same current that passes R1, right? And it's the same that will pass R2 to back to the supply, right? So we know that current IT is the same through each resistor once it's in series, right? And the voltage now is the difference, because if these resistor values are different, then according to Ohm's law, if the resistor values are different, even if they have the same current, their voltage will be different, because V is equal to IR. So in this case, the voltage, total voltage, right, being supplied by your battery will be the sum of your individual voltage, all right? And we know that the total resistance in a circuit would be the sum of the individual resistors. So in this case, we have two resistors, right? So it's R1 plus R2. If it's three resistors, then it's R1 plus R2 plus R3, all right? And then we look at the parallel circuit, which is the current takes more than one path, all right? So in this case, this is like reaching a crossroad while you're driving, right? So you can turn left, right, or go straight, and you can actually meet at the same point even if you turn any of those directions, right? So it's the same thing with current. So in this case, current leaves the battery, right? It reaches at this junction right here, right? So this here is called a junction, right? So it's going to it reach a junction, so it can branch off. So this is a branch, right? So it branches off to, some will go through R1, right? And some, notice it can actually go through R2. So when current reaches the junction, it splits, so some goes through R1, some goes through R2, and it meets back at this junction here to make it go total right there, right? So at this point, this is I1 current, and this one is I2 current, right? So I1 and I2 comes back right here, and we start traveling at IT, right? So we notice now, because these two branches, right, we have IT is equal to the sum of the branches current, right? So I1 plus I2. Now the voltage is the difference in the charge concentration from the left side to the right side, right? So because we're putting the voltmeter across the same left and right, right? It doesn't matter if it's on this branch, or the battery supply, each will give you the same reading, right? So the voltage in a parallel circuit is the same on each branch, right? In a series, the voltage is different depending on your resistor value. But even if these resistors are the same or not, it gives you the same voltage reading, right? And then the total resistance in a parallel circuit is 1 over RT equals 1 over R1 plus 1 over R2. Now, this equation is sometimes not properly used by students, right? So let's put in some values and work these out. So let's say this is a 3 ohm resistor and this is a 2 ohm resistor, right? So therefore RT will be a sum of each resistors, which is 3 plus 2, so we get a total resistance of 5, right? Let's say we're using the same, so this is the 3 ohm and this is the 2 ohm, right? So in this case, it's 1 over RT would be equal to 1 over 3 plus 1 over 2. Right? Then you know from math we'll find the LCM, which is 6. Right? So 3 to 6, 2. And 2 into 6, 3. So we get 5 over 6. But 5 over 6 is 1 over RT. Right? So to find RT, it's basically we're flipping that number there. So RT is 6 over 5. Right? Which is 1.2. Alright, now there's a reason why I did this with the same resistors, to show you that the total resistance in a parallel circuit is always less than the individual resistors compared to when they're in series. So this is very important if you want to connect some resistors or appliances and you want to get a very high resistance because you don't want a lot of current to pass through them. Then you connect them in series because it just adds their resistance together. Well, let's say you want a high current right? Then you want high current, so therefore your resistance needs to be low. So in that case, you connect them in parallel, so you get a very low resistance compared to their values that they are. All right, so that is very important in connecting. So that's the reason why, one of the reasons why our appliances in our home are connected in parallel circuit. So you notice your light especially, right? So sometimes there's two switch right beside each other, and you could select one and only a specific amount of light turn on, and you select the other, the next light turn on, right? So it makes operating something independent, right? So if you just want two lights to turn on, you can just switch one switch. If you want all lights, you can switch both switch, right? And let's say there's something wrong with one of the bulbs. If it was in series, none of the bulbs will work, because if this is not working, it blocks current to meet the other one. But if this is not working, we still have current flowing in this one, so we still get something working. All right, so that is an advantage as well of using parallel circuits in our home wiring. All right, so let's look at two questions that will use all these formulas and see if we understand fully circuits. Alright guys, so our question here shows just a section of the circuit that is needed, right? And we're asked to find the total resistance. So a very good problem here is we need to know what type of circuit we're working with first. Alright, so we check on where the current is going. So the current goes through point A, right? And we notice at A the current can split. So some current will go up while some current goes there, right? But we also notice that there is another resistor here. So we need to know what's the relationship between this resistor and this resistor, this resistor and this resistor, right? So remember from our previous that if the current is going through the same current passing through resistor 1 and 2, they are in series, right? So let's check. So the same current passes through 8 will go up and then come down through 4, right? So that means the relationship between 4 and 8 is that they're series, right? So they're in series to each other. And these two are in parallel to the 6, alright? So because we have two types of circuit in just this one arrangement, we call it a series parallel circuit. Now, how do we calculate the total resistance? Now, we look at the part that has two of the same, right? So we have two series, right? And just one parallel. So what we basically can do is to resolve your series first. So if we find the resistance in the series, then it would be 8 plus 4, which is 12 ohm, right? And what that is that it changes the circuit to look like this. So instead of two resistors, we have one resistor at the top measuring 12 ohm. So we have a resistor at the top measuring 12 ohm now because these two added together. So now we can find the total resistance because they're in parallel. It's 1 over 6 plus 1 over 12, right? The LCM is 12. 6 into 12, 2. 12 into 12, 1. So we get 3 over 12, right? So remember this is 1 over RT. So RT would be flipping this, so it's 12 over 3, which is 4 ohm, right? So that's how we would find the total resistance. So because these two are in series, we find the series first, which gives it one big resistor of 12 ohm, and then these two are in parallel, so we work the parallel, and that's our final answer. All right, so that's A. And then B says the potential difference between A and B is 12 volts. Right, so we need to calculate the current that's flowing into junction. Right, so if this is your 12 volts, that tells us that the voltage total is 12 volts because it covers all resistors, right? So the total R, which we just found to be 4, right? And the question asks us to find the IT, because what's going into junction 1 before it splits would be your total current, right? So total current is equal to V total over R total. So V total is 12, R total is 4, so we get 3 amps. All right, so your current that's flowing into this junction is 3. And then the final part is determine the current in the 6 ohm resistor. So now this is where this current will split into 2. So some current will go up here and some would go there, right? Now let's just, by looking at it, let's just show you how you can know if your answer will be somehow right. The relationship between resistance and current is that they're inverse. So if you have a low resistor, you're going to have a high current, right? So remember at the top, it's experiencing a 12 ohm resistance. So that's a high resistance compared to a 6, right? So that means if it's 12 ohm here, then that means your current is going to be low. So your current through this branch is lower than your current going through the 6 ohm. So let's check, right? So we're finding for part C, you're finding I through R. Let's do, so the I through the 6 ohm, which is your V, right? And what V do you think you use here? Right? So remember these are in parallel to this, right? So therefore, because this is in parallel to this, the voltage that is here is equal to the voltage that's here, which is equal to your voltage, your total voltage, right? And that's what we did. The total voltage in your parallel circuit is the same right throughout for each branch. So this is one branch and this is another branch, right? So the voltage through the 6 is the same 12 as the voltage between 8 and 4. Alright, so the voltage that we're going to use is total voltage over, because we're using the resistor 6 ohm, we have to be specific to the 6 ohm now, right? So we're not using the total T because we found the total I, so we use total T. We're finding the I at 6, so we have to use the R at 6, right? So the total voltage is 12 over resistor 6, which gives us 2 amp, right? So that means if 2 amp is flowing in this direction, then this branch will have a total of 1 amp. So when we add 1 and 2, we get 3. All right, so if there was a next part that says what's the current flowing through the 8 or the 4, then it would just be this minus this, we get 1. All right, so that's it for this question. Let's look at another one. All right, guys, so the final question here. All right, so again, we check out the type of circuit here, right? So the first part says when the switch is open. So we notice there's a switch here on this branch. So when switch is open, that means there's no current flowing in this branch, right? So basically, what we can do is we can ignore this part of the question for when the switch is open, right? So when the switch is open, this is all we have here, all right? So when the switch is open, calculate the value of R2. So R2 is unknown, right? We have R1 and we have the total current that's flowing because this is now is a series circuit, right? So current flows through R1, R2, then flows back to the supply. Now current does not flow through a voltmeter. So a voltmeter cannot be connected, not be noted as its other component that's connected in parallel, right? So current flows only through this gap here. So that means we have IT, which is 2 amp, right? And we know that the total voltage is the 24 from your supply, right? So we can find total R, which is VT over IT. So VT is 24, IT is 2. So we get 12 ohm, right? Now we know one of the resistor, right? And the other one is unknown. But we know that because it's a series circuit, RT is equal to R1 plus R2. So R2 would be RT minus R1. So RT is 12, R1 is 4. So we get R2 to be 8 ohm. So that's how we would find the voltage. The resistors are part B. What's the reading of the voltmeter? Alright, so now we know that the voltage between these two will be different, right? Because there are two different resistor values, right? But their current is the same. So we know that the voltage in R2, because that's where the voltmeter is equal to the IT times R2. So I is 2, R is 8, so we get 16 volts, right? So that's the voltmeter reading, right? So if this is 16 volts, then the voltage in R1 would be 24 minus 16, which is 8, right? So if another question had asked what is the voltage in R1, then that would be 8 volts, because when you add, you get back the supply, right? So now the switch is closed. So now we need to introduce back this part, close that switch, right? So now when the switch is open, we have a new resistor, and we need to find what's the voltage right there at the same point, right? So because we have a new resistor here, right, we have to take that into consideration, because these two, when current reaches here, it will go into split. So some goes there, some goes there, right? So if these two are in parallel to each other, right? So we first have to redo the RT value. So this is the parallel side, so we find the R at the parallel circuit, right? Which we know is 1 over R is 1 over R2, which is 8, plus 1 over 8, right? 1 over 8 plus 1 over 8 is 2 over 8. So therefore, this voltage, this resistance, sorry, is 8 over 2, which is 4 volt, right? So the total voltage, total resistance here is 4, but it's in series to this 4 as well. So therefore, the new RT voltage would be the 4 plus 4, which is 8 ohm, right? So we get a total RT of being 8. So the previous RT was 12. Now this one now is 8, and that's because we introduced a new resistor that is in parallel to it. Alright, so now we have the total resistance, right? We're asked to find the voltage at this point, right? So we know that we know for one that now the current will be different, right? So we have the total R, so we can find the total I, which is VT over RT. So VT now is 8. So this now gives us 3 amp. So the current now is no longer 2. You've reduced the resistance, so your current now increases. So it increased to 3. So now let's find the voltage, right? So the voltage would be IR. But which I would it be? So we can do it both ways. We can find it here, right? Which is easier. So we can find the voltage at R1, right? Which is your total current times your R1 value. Your total current is 3 times 1. 3 times R1, which is 4, which we get 12 volts, right? So therefore, if 12 volts is here, then the rest of voltage will be right here. So therefore, your answer, let's put this in a new thing so you can see it. So therefore, your answer now would be the 24 minus your 12. So therefore, you have 12 volts reading for your voltmeter, right? So previously, when the switch was open, it's at 8 volt, but because now you've introduced a new resistor that makes the resistance lower and current high, you get a higher voltage of 12 volts. Alright guys, so that's the process in which you will use to do any calculation in terms of circuit. Alright, so thank you very much guys for watching, and see you guys next time.